Well, hi, good morning, and thank you for joining me in my shop for a start on this radio. Now, just before I get started, since this is the first video, there's a good chance you're a new viewer. If you're not a new viewer, you know what's going to happen here, but if you're new, you're not so sure. Basically, it's quite simple. I come in my shop in the morning, I turn on the cameras, and I start working. And I talk while I work, and I say lots of stuff about radios, about some significant portion of it's probably not quite true, but nevertheless it comes out of my mouth. And you watch while I work, and I try to make these radios come back to life. I get radios from various sources. I seldom buy them. I very seldom buy them and sell them. So the radios kind of find me, and it's obviously because of the kinds of things I'm doing here. So a lot of these radios are other people's radios. This particular radio is on its way to a second time around store in Toronto who pick a lot of old radios as they travel around, and then they collect them together, bring them up to me, and I run through them in my shop like you see, like I'm going to do with this one. And the idea is just to make them safe and ready for sale if possible. That's my objective. These things don't sell for a lot of money, so not a lot of money can go into them, so there's not a lot of money involved in any of this, quite frankly. So I follow a fairly basic, straightforward process. It starts with an inspection, then usually a decision as to whether I want to start the radio up as it is, which I usually make an attempt at. And then I focus in on making the radio work to any degree at all. I try to find a part or two or whatever it might be that's completely stopping the radio. Get it working a little bit. Once it's working a little bit, then I just go into sort of a restoration process and replace parts that should be replaced at this point in time and watch the radio's performance improve. And then the last step is to align the radio, which is to do the internal factory tuning things to bring it fully up to its potential. When I start, I have no idea where this is going. I don't know if this is a 1-hour project or a 10-hour project. I don't know what I'm going to encounter along the way. I don't even know for sure I'm going to be able to fix this, although my record is really good, and I think anybody's would be if you're just persistent with these things. I work in a shop that's full of also vintage equipment that you can see here. I kind of like working with the vintage equipment. It's all part of the deal. The only thing that's not vintage here is me. That's not quite true. I've got some modern stuff. I've got full meters and things like that. But generally speaking, I'm using equipment that's rather dated, and like a lot of it has tubes in the equipment itself. So, okay, enough talk. Let's take a look at this radio and see what we can make of it. So my first impression is it's an okay looking radio. Most radios are kind of okay looking. This one has some interesting details in the cabinet. It has these stripes here. It has the waves here, which are probably symbolic of the waves of sound coming out of the speaker. It's got all of its knobs, which is a really good thing, and those are the correct knobs. The cabinet itself is beat up. It's taken a beating. There's a split right along here. These cabinets are usually built pretty strong. This is split along the same line here, so we can kind of see what's happened here. So lots of glue thrown in there. She'll be back just like. Oh, this one's not quite separated, but the crack is formed here. Here's a note to me. No power, could be cord. Yeah, take a look at the cord. I mean, look at this thing. I can't believe that people actually own this, actually plugged this in to see what would happen. Whoa. I don't think that's quite bare metal here. I think that's another. Yeah, there's some bare metal right there. So it's actually got insulation under the rubber here. That's the only wow. That's the only reason they plugged this in and it didn't go boom. Yeah, this cord is I think it's seen better days. So it's probably had this. It's got a twist tie. It's probably had the twist tie on it forever. So I just gotta cut it off because it's nothing more than in the way. And it's shattered, in fact. Okay, I'll put that where it should go. Garbage can. Now, a couple things right away. that's asbestos there, and you can see the sheet has been torn away here and torn away here. Who knows why or how. You want to be a little bit cautious with the asbestos and not rough it up and cause fibers to be released. So just kind of be aware that it's there. This is rather interesting. This note, I've never seen a note quite like this one. This one says, built to receive television sound. I quickly look for a phono input. I don't see a phono input anywhere. Built to receive television sound the wireless way. When used with Philco television picture receiver, without wires, plug-in, or connections of any kind, that's the end of it. That's the end of the sentence. I didn't quite read it right. Built to receive television sound the wireless way, when used with Philco television picture receivers, without wires, plug-in, or connections of any kind. Really? So this is bound to be the antenna hanging out here. How would this work with it? Maybe the Philco television receivers had transmitters in them that would transmit on AM or something? I don't know how this works. Never seen a note like that. Oh, more notes inside here. So here's a tube layout. These are all 7 tubes. They all start with the number 7, like 7, A, 8, E, it looks like it says there. I'm not sure what the E is. So when tubes are denoted with the number 7, they're actually 6-volt tubes like many other tubes. The 7 is to distinguish them clearly from all other tubes. Now these ones are called Loctal tubes. They have a metal center pin that actually goes into a grip. So when you put the tube in, it's gripped and held. I think these were really intended for automobiles. What's shaking about this radio that the tube would shake out? But in any case, they're in here. Otherwise, they're the same tubes as other tubes. They have what's the word? There's tubes with ordinary numbers on them that do the same function as these tubes. So they have funny numbers, but they aren't funny tubes. I guess that's the way to put it. Philco. So this is a Philco 25, 30 watt radio, 25 or 60 cycles. Do you see a transformer in this radio? I don't see one. And we will now do the tube count. 1, 2, 3, 4, 5, 6 tubes. So they're probably in series. The heaters are probably in series. And this one looks rather unusual. It says here right on the tube, when renewing, insist on a genuine Philco tube. Yeah, that's where a lot of money was being made, in selling tubes. Some kind of a band here, and a funny shape in the chassis. Got a number over here, D2225, and I can't see anything else. No evidence of ever having been taken out of the cabinet, but you'd have to think most of these radios have gone in and out a couple of times before they get here. Radio's held in by 3 screws. Okay, I think we gotta pop the chassis out and take a look at what's been done, if anything. So we'll pull the knobs off here. There we go. There's too much to worry about. It's a small radio with gaps at either end here, so if I take the screws out, it can fall out. I think I'm gonna do this rather unusual thing. I'll put it this way. That's not how you would normally put these guys. Let me take this one out first. The cabinet's missing one of its corner blocks. quite common. You know, when I look at a cabinet like this, I think, wow, somebody had to work pretty hard to build this thing. Cut and shape and then fasten together all this wood. As opposed to the plastic modern cases, modern being in the 70s and 80s. They're just molded in a... There's a little labor, but isn't that the story all the way along? Things that require a lot of labor get replaced by things that don't require as much. Did I lose a washer? Ooh, what was that? Something slid past my hand and went down into the radio. I think it was a piece of debris from the, there's the washer there. Okay, it's gonna stay. Piece of debris from the power cord. Okay, take this back up. I should be able to pull this out. Once again, I don't really want to disturb the asbestos. So I'm grabbing rigid parts here. Gotta watch out for the plates. I'm gonna get it from the sides here. Okay, lift it up. I'm looking to see, like this asbestos often sticks. See, it's sticking right here. Something more holding this in. I think it's stuck on the asbestos. There. So get. Okay, so we'll put that there and we'll take a look in here. Well, it's bits and pieces of debris from the, I thought it was mouse turds at first, but it's not. It's plastic debris from the power cord shatter. Okay, not much to see in here, really. Another note here probably saying, hey, you need a license to operate this radio. Okay, I'm going to set the cabinet aside. We'll deal with the asbestos. I'll deal with it later today. I'll take that out of my garage. And I'll almost certainly take out the asbestos sheet and wrap it in a plastic bag, like a grocery bag, just an ordinary plastic bag. Double bag it and it goes into the regular garbage. That's how it works here. Okay, well, look at the speaker. Holy smokes! What happened to that? Wow. Okay, somebody's been at this. So, wow. There's a huge piece here. So this speaker had a huge tear in it, I guess. And then somebody's done that to it. Now the chances of it not rubbing against the... I don't know, boy. Wow. Well, somebody's been at this radio. If they did all that, gotta wonder what they did underneath it. It'd be quite a while ago, because look at the dust on this thing. Again, anybody who did this kind of stuff would have probably cleaned all these tubes off. So it was a long time ago that was done. Okay, let's look underneath. Oh! Okay. She's jammed in there a little bit. Nothing been done under here. This might be original, this might be replaced. This is the filter capacitor here. And I'm bound to replace this. I mean, there's no question. Take that out like I'm doing some kind of operation on somebody. Did you know that? Doctors lift your organs out when they're working on you. So, wax capacitor here. This looks like something very special, in fact, this one. Philco used special capacitors that they had prepared in some way. Let me get my close-up camera going here. And the camera I use for close-ups is really what I should say. In fact, you know what? It's break time for me and some coffee. Yeah, that's a good idea. Okay, you can see my little camera aimed right at the two interesting capacitors there. Let's see what we can see here. So, interestingly enough, they are tied together at this end, and that goes straight to the chassis. Kind of unusual that they would bother binding these wires together. on their, see, they're bound on, they're twisted together on the other side too, which is again unusual. So this looks like a unit, this thing here, that was put together outside of the radio and then installed. You can see this capacitor has some wide piece on it, something else wrapped around it. I'm going to take a guess. It's either a shielding or it's a coil. Looking for any hint that there's wires under there, and I don't see anything. Sometimes you can see the shape of the wires under these things, but not this one. Okay, well, we'll have to look for that on the schematic when we get around to it. Sometimes you can just replace these with standard capacitors, and the loss of performance in the radio is not really noticeable. Okay, any other tricky stuff in here? We'll just start in the bottom corner and work our way upwards here. And I'm looking for burned out resistors or cracked capacitors or just anything that just doesn't look right. And the parts jammed right down in the right down in there. Okay, so here's the band switch. This is a 2-band radio, a broadcast band, and the other band is what was called the police band, which is just basically continuing above the AM band up to a couple megahertz or so. Remember seeing movies when you were a kid, or TV shows, and the cops would pull up in their car and they have this gigantic whip antenna on the back? That's because they were transmitting at these crazy low frequencies that we would never use anymore. Chunks of asbestos all over the place here. So I'll get a wet paper towel and I'll wash off all that asbestos. So here's a... Well, there's nothing jumping out here so far at me. You can see here the locking part I was talking about with the vacuum tube. It's just a little weird how that's that terminal is done there. That must just be the ground terminal for the center post. And you can see the tube pins coming through. It's a different kind of socket, but you can tell that it's locking right at the top there. It is. Okay, so this is probably an output transformer here. It's a little unusual that it's underneath, but I guess there's no room above. Anybody hear anybody yelling? Somebody yelling? Now this looks like a Hunt's capacitor here, molded capacitor. Probably needs replacement, and then there's another one here. Now, this one looks different than the other capacitors. It's Plastiseal. So you gotta ask yourself, I'm asking myself, they got this kind of capacitor, this kind of capacitor, and these more typical paper capacitors. Well, why the different capacitors? These may be replacements, just maybe, early in the life of this radio. Relatively early, I don't know. Okay, hard to say. Offhand, I'd say nothing's been done. This is a big resistor here. Did you notice how I ignored my cat and it just went away? That was amazing. And those numbers, I think they're just a part number. So you see how this big resistor is attached right to the chassis. That's for cooling, of course. And what about, where'd the volume control go? So that's the string. And this is the volume here. That's the on-off switch terminals. Okay. I'm so surprised my cat gave up. Look at this big batch of asbestos here. So I got to clean this asbestos off because it's going to start flaking a little bit. And why don't we just take a look and see what has happened to the cat here. Oh, she's waiting for me down there. Is that right? You're waiting? Yeah. That's the response. Have I mentioned? She doesn't know it, but 2 kittens are coming here in just a couple weeks. We're going to have 3 cats again in our house. I don't know, is that a good thing? I'm not even sure. Okay, I'm going to stop for a little bit, deal with my kitty cat there. Okay, asbestos is gone, for the most part anyway, and so I really like trying to operate these radios before I start working on them. Unless there's something really dramatic, I'll make a small change and then try to get the thing operating as soon as possible. Once a radio is working a little bit, then you can continue to do stuff to it, and you can tell if things are getting better or getting worse, or if you've made a mistake or something like that. But if you, so this wire is coming up here, going across to the other side somewhere. And what was I saying? I don't know. Where'd my cloth go? I should dust this off too. Make it look a little nicer anyway. Yeah, I would normally kind of do this off camera, but you're here now, so. So a lot of this dust is going to have asbestos particles in it, and getting rid of it from that point of view is kind of good, I guess. I guess in the big picture, asbestos saved a lot of lives because it's a fireproof material and was used extensively in fireproofing. All kinds of circumstances here. I'm wiping the top of these tubes where the numbers are written, and I'm wiping off some of the numbers so I can see. That's not good. So it's hard to say how many, what the good and bad of something like that really is in the big picture. How about polychlorinated bipheноls, a chemical that is dear to my heart, PCB. It was a big deal years ago, but you never hear a word about it anymore. It's like the world was going to end because of PCB oil. PCB oil found its way into the electrical industry because it was electrically inert, I guess I could say. And most importantly, will not support an open flame. It doesn't burn on its own. So that stuff, just like asbestos, was used in many circumstances where you couldn't tolerate a fire. One of the best examples is the CN Tower in the city of Toronto. There's a very, very tall antenna tower, basically, with a restaurant halfway up. Way up, like 1,000 feet or something like that. And so that tower, here's the tower. So there's a pod way up here, way up here. Now how are you going to get the power up there, 1,000 feet up? So you could put transformers down here and send the power up. But this is an antenna, and it's driving a lot of power off of these antenna elements. A lot of power up here. So instead they ran cables, high voltage cables, all the way up to the pod. And at one level of the pod they put transformers in there. Now what kind of transformers are you going to put in the CN Tower? Ones that you never have to be concerned about burning up and burning the tower up. So they're Ascarel filled transformers. Ascarel is, 50% polychlorinated biphenol, and good stuff for transformers. And a lot of transformers in this exact same situation, only not the CN Tower, but other tall buildings where they decided to bring high voltage halfway up, transform to low voltage, and then cast it through the building. Those transformers, if they're filled with ordinary oil, are like bombs in these in these buildings. If they ever caught fire and leaked their oil out, the oil would pour. I mean, wow, it would be a disaster. So yeah, Ascarel. Well, those transformers in the CN Tower are no longer Ascarel filled oil transformers. They are now dry type transformers. The original, and here's the thing about the CN Tower, is that those transformers were installed by crane while the tower was being built. There's no way to get them out. These transformers are great big things, size of a car. There's no way to get them out. So what they had to do it's hard to believe, is drain out the oil, take everything down through the elevator system, chop up the transformer tank, or disassemble it. I think it would chop it up with a blowtorch. I don't really know exactly what they did, but anyway, they took it down in pieces. Then they brought the new transformers up in pieces and assembled them up in the tower. And all this went on during the PCB craze of the late 70s and through the 80s. Well, there you go. Okay, I got off on a wild story there. Is there any PCB oil likely to be found in a radio like this? And the answer is basically no. It's expensive oil, and this is a cheap radio. They're not going to waste polychlorinated biphenyl oil. And do they use it today for anything? I don't know. Don't know the answer to that. And what was the problem with it anyway? It's a live forever molecule, number one. It is very hard to break down. So it's collecting here and there and everywhere. And the last one is, if you do break it down, you need a high temperature, like a frying pan temperature. You can break it down. It won't burn, but it will smoke, and it will turn into one of the most poisonous materials on Earth. That's the real problem with it. Don't burn that stuff. Now, I won't go into the story, but there's a story about something that happened in Japan. I believe it was Japan. That started the whole PCB ball rolling. Okay, enough of that. That's old history because nobody cares about it anymore, even though it was front page news for like a year. Way back when. And it's funny how those things go, eh? Things become super important and then they kind of slip away, and maybe because they were dealt with. Well, I just think other things catch people's attention and take over. Should we turn this radio on? So there's nothing staring me in the face here that says, no, don't turn this on. No, I wouldn't plug it right in the wall and hit the switch. I have ways of restricting the power. Oh, I can't turn it on. There's yeah, I can turn it on all I like. I need a cord. I need to do the cord. Right. I almost forgot. So we can see the cord comes over to this big resistor terminal here, and the other one's got to be going to the switch over here. So these pieces of wire, there's a crack in it here. They're all stiff. So this is all garbage here. Okay, can I forget which terminal? I don't think so. Oh, listen to it. That's the insulation cracking off. Okay, cut only this wire. Out you go. Okay, I got to find a new wire. We're going to wire it up, and we are going to plug this thing in and turn it on and see what happens. Yeehaw! Not that replacing a cord is all that interesting, but... So I've picked a non-polarized plug for this radio. These radios have a danger with them, and that is, we'd have to look at the schematic to find out to what degree. In some of these radios, the chassis is essentially attached directly to one of these prongs. Now when you plug this in, because it's not polarized, it can go this way, that way. So 50% of the time, just by luck, the prong that the chassis is connected to is going right into the live outlet. And this is as live as sticking your finger in an outlet. The different radios are done different ways. I guess as time moved forward, they adopted more and more safer practices, but you certainly can't. I mean, if this is a fully live chassis, it's something you would never find today. I don't think you could ever find anything like that. You know, back at the time this radio was made, outlets only had 2 prongs. They did not have the third green wire ground, and so the issues of getting a shock had to be dealt with at the device level in a different way. Then this is a huge terminal here. It's just got a ton of stuff all over it. How am I going to get a wire around there? I think I gotta strip this even more. So a lot of the techniques were dependent on keeping people from touching stuff. So there'd be a warning on the cabinet, you know, no user serviceable parts inside. You know, keep your hands out. The knobs on the controls, like if you look at the tuning control here, right, the string is attached right here, but this control is metal attached to metal. It's just part of the chassis electrically. So if you were to able to touch that knob, you'd be able to touch this chassis. And if this is one of those radios, and you were at the same time hanging on to your kitchen sink tap, you might be singing louder than the radio at that point. So I'm going to have to just soak this up with solder here. This gave rise, in some of these, the chassis is not directly connected, but is connected through a capacitor and a resistor. And that gives rise to this weird thing I saw when I was a kid fooling around with these radios, where you could drag something on the chassis and sparks would shoot out, but nothing bad was happening. And, well, what's all that about? How come you can get sparks, but the lights aren't flickering in the house? What's going on? And that's because it's coming through a capacitor. And solder, please. Here we are. Yeah, I think of all the things I did when I was a kid. How it is I'm still alive, I really don't know, because I did crazy stuff with electronics, old tube stuff like this, so I didn't really appreciate anything about it. Yeah, really. I love to learn by doing. That's kind of what's happening here in front of you. And I think a lot of people do. But there can be a price. Hey, there's always a cost to education. You can identify it always. When somebody is learning something, there is a price being paid for that. Sometimes it's the person themselves. It'd just be the time involved. So you have a productive person who has to stop their work to teach somebody something, and the productivity stops for that person. That's the price being paid, while somebody learns something. There's always something like that. I got to get in behind this capacitor. I really don't want to change any parts yet. I think I can push this guy over though, and get in behind him here. And I think I'm going to pick out the old wire. I don't know. I don't have any particular stories, but I'm sure if you let's see if I can get it out of there. I'm sure if you were to go back in history, you'd find out all kinds of electrical accidents were happening. That would never happen today because things are done differently now, but back in the day all kinds of risks were being taken, I'm sure. So in Ontario here where I live, this is one of the early power adopting areas of the world because of Niagara Falls and the electricity being generated there very early on. Everybody's coming off the terminal here. So I've accidentally desoldered this capacitor. I'm really trying to make no changes to this radio while I do this of any sort, but I forgot what I was talking about, of course. Safety in the electrical system. I know what I was going to tell you. So the province here, Ontario, like many jurisdictions, developed companies to start working with the new technology and start spreading electricity around. And initially, for mostly for industrial purposes, big motors and that. But and then eventually developed the provincial system we have today. Up until the 1950s, the death rate at this company was called Ontario Hydro. The death rate was roughly a worker a day. I can't even say that and believe it. Worker a day? Sometimes they were losing 4 workers at once. But how do you do that? You put them in a boat because they're working on a dam or some water project like that related to hydro. You put them in a boat and the boat sinks and they die. And yeah, a death rate that was crazy. Just crazy. Talk about sacrifice for society. And maybe at that time it was kind of a, hire another guy. I don't know. It's hard to believe, really, that that kind of death rate was tolerated. Yeah. So the fact that our societies run today and we don't have these enormous death rates really says something about how human beings have developed their industrial systems. We're no longer sacrificing people left and right. Here's a good story for you. So in the city of Toronto at the turn of the century, there was a transit system developing, a streetcar, and but the streetcars were not electric. They're pulled by horses. That's very common back in the late 1800s and that. So the streetcar's on tracks, but a horse is pulling it. So the horses. So this is all through the winter. These things are operating. The winter's very cold here. It can be very cold here, and very hard on horses. So they took good care of the horses. The horses only work for about 4 hours, and they go back to the horse barn, I guess, in the city, and be taken care of by people who livery guys, I guess. Livery, would that be the right word? And the horses were cared for very much. If a horse were to die, they had to buy another horse. That cost money, getting another horse. And they were investing heavily in these horses, feeding them and all that kind of stuff. So they really wanted to take care of those horses, keep the transit moving. Now what about the people? So the driver sat outside of the streetcar body. So the passengers are inside, and they had a little fireplace going in there to warm it up. So they're inside. The driver's outside at the front here. And the ticket taker also is outside of the heated box. He goes around the outside, has like a thing to hang on to and walk on. Around the outside, reach in through the windows to take money or tickets or whatever it was. So he's on the outside, the other guy's on the outside. And these guys had to work like 10-hour shifts or whatever. And accidents happen. They'd fall off, get killed. And horses taken really good care of, because you had to buy the horse. But the people, there was a lineup of people looking for work. So if one of them fell off and got run over or stepped on by a horse and couldn't work anymore, throw him aside. There's another guy at the door. Bring him in. And that's kind of how it was back then. Take care of the horses. Who cares about the people? Yeah. So I think we live in a very different world now from that. Okay. Now focus on what you did, Jim. You're yapping away here for no good reason. Kind of entertaining yourself. I think we're ready. So I'm going to leave the guts sticking out here. Why shove it back in? Just leave them hanging out. So when I start this guy up, do I expect it to receive? No. No. In fact, what I expect is I'll turn this thing on and one of two things will happen. Nothing will happen, or it will hum like crazy. That's my guess. Hum like crazy. So first, switch off. Band on broadcast, is it? Assumably, this is not a good way to do this. That's broadcast. Okay. So again, switches off. Now, when I plug this in over here, I'm plugging it into a dim bulb system. I see there's a lot of videos on YouTube on how to make a dim bulb system. I wonder if I popularized it here, because I've been using this kind of technique from day one, doing this kind of work. So what's going to happen is I'm going to supply power to the project here, but it's going to go through these lights. Yeah, so these lights are like a big resistor, if you like, that glows. So if the radio draws an enormous amount of power, the lights would come on enormously bright, and they can be fully bright. If there was a complete short here, the lights would come on fully bright, just like they were turned on in an outlet or in a socket. Nothing bad's happening anywhere, except I know that there's a short. So that's the idea of these lights. The second idea is the lights actually give you some notion as to what's going on in the radio. In a radio like this, normally when you turn it on, tubes are cold, tube heaters are cold, current rushes in, might kind of rush in for a second or two, Heaters begin heating right away, of course. As they heat up, resistance goes up, current goes down. The response on the light is, turn the set on, the light comes on bright because of the demand for current, which it's restricting, by the way, and then the light will go dull. It may go right out, it may stay out, but chances are it'll come back on again slowly as each of these heaters heats right up, heats up the cathode in the tubes. The tubes start to conduct. They start drawing power, drawing power, drawing power through the light. So to go over it again, very simply, turn it on, the light comes on strong, goes down, then it starts coming up again, then you hear the radio usually in the coming up part, and then it stops. So it actually starts way up here, goes down here, ends up down here. That's kind of how it goes. So we can watch this as an instrument telling you what's going on in the radio. But like I said, probably this radio, nothing will happen, or it's going to hum like a son of a gun. That's my guess. Switch is off. I'm going to apply power first of all to prove the switch can be turned off. So you can see this switch I'm about to throw. If I push it down, power goes through the lights. I'm going to make it just one light to start, just a smaller bulb. If I flip the switch up, power bypasses the bulbs, goes straight here. So I'm basically attaching this to the Bruce nuclear plant, which is not too far from here. Okay, are we ready? Sure. Okay, so you might have seen this meter pop up. This is kind of a, it's not a serious meter. But this goes from 110 volts, it doesn't go to zero. It starts at 110 and goes to 140. So you can look at that from a distance to get a notion of what's happening. I have this device, this very handy device, plugged into this the outlet that I use for powering projects on my bench. And it shows 110 volts. It's 110 because of the setting here. So just I have to explain this a little bit. In order to make this safe, especially this kind of radio, I have an isolation transformer operating. So the power that's getting here is coming from the secondaries of a transformer, and the primary is hooked up to the Ontario hydroelectric system. The benefit of that is there is no electrical pressure between the secondary side of the isolation transformer and earth that I am standing on, where I'm standing on a concrete floor. Actually, I'm standing on a tiled concrete floor, and I've got a rug, and I've got rubber-soled slippers on, so I'm far from earth. But that's the idea. There's no relationship between the power operating in this radio with the isolation transformer and the earth. So I cannot get a shock to earth. You still get shocks. Still got 120 volts here. You still get shocks off it. But you can't get the grounded shock. Okay, so obviously the switch has worked. Ooh, don't stick your finger in there. So now we're going to turn this on, but I'm not going to turn it on here. I'm going to click it off here, turn it on here. And why? Because I'm a chicken. If I need to cut the power quick, I don't have to reach my hand over to the radio. I got it up here. So this time we expect the lights to come on bright, go down, but then come up a little bit. Here we go. She's on bright. She's going down. It looks different in the camera, by the way, than my eyes. I can see the filament with my eyes. You can't see it. The light is on here. Better turn the radio up a little bit. Now when you do this, it restricts the voltage at the load enough that sometimes there just isn't enough here to even operate the radio. And that could be the case here. We're up at 68 volts, 69 volts now. You got to be around 90 volts usually for a radio like this to come to life. Oh, I heard a little pop come out of the speaker. Or was it this? Maybe it was that. Okay, so the best way I've got to jack the voltage up a little higher, we're aiming for 90 to start. Oh, I hear it. It's a hummer. Now that could be a received hum, very unlikely. No response on the volume, that's a little odd, but maybe only half the radio's operating right now. We got to raise the voltage more. So my options are to turn it up with this, or screw this other light bulb in. So I'm going to go for the other light bulb. I don't want the whole thing to show up here voltage-wise, so I'm going to turn this down. I'm going to screw in this light. It's going to go right up to like 110 volts or something. Let's see what we get to. 90 volts. Good. It's almost dead on 90. Funny coincidence. Now we're going to see if we can hear anything. No antenna. We can't hear anything without an antenna. Whoops, I overlooked something. Okay, so I'm going to cut this off, take a little break, set up an antenna here properly. I have an outdoor antenna with a feed into the shop here. I'll hook it up, and we'll give this thing an antenna, and lordy be, I think it's going to work. I think it's going to be working. Okay, let's give the radio another chance. I'm going to switch it back on, again through the dim bulbs. This time they didn't glow because I have the two of them here. Plus, probably the capacitor in the power supply here was still charged a bit, which I guess is a good sign. 91 volts. So my antenna terminates, my antenna lead coming in the shop terminates in this box. So it's on this clip lead here. Okay, radio's operating. So the first thing I'm going to do is take the antenna wire through a capacitor onto the center wire of my outdoor antenna. My outdoor antenna is a mini whip, which is actually a amplified antenna. You can hear that a little bit. You might hear the same thing if I touch the chassis with this though. A little bit of crackling there. Anybody home? Okay, is that a radio station? So I think those are radio stations. That's full volume. Judging by the position of the pointer, and I know where the strong stations are, and assuming this is relatively accurate. So no, it's not picking anything up that we can hear. Now I do have the antenna, just the center lead connected. It would be better if we could work it like this. Hook the ground up to the chassis. I'm nervous today for some reason. I'm going to just check it with a voltmeter here. Now checking with a high impedance voltmeter can be very misleading. You can read voltages that appear to be of significance when in fact they aren't. AC, right, so 600 volts AC. Is there in, no, could easily get a reading here on this meter. Let's see what we get. Ooh, that's good. Nothing. That's good. I like that. We'll go with that. So I'm going to put the ground connection onto the radio here. Okay, everybody, look away. Look away. Do you do that too? Didn't seem to make any difference whatsoever. I don't think it made any difference. No. Again, I suspect that's a radio station. Speaker works. Things are being amplified. Effects on the antenna. Seems to be some relationship between the antenna and the speaker. That's good. The heavy hum is almost certainly coming from the that capacitor that's hanging out the back. So, okay. There we go. I think that's going to be it for today. Tomorrow I'll start actually working on this thing. We'll start with the power supply capacitor and just slowly progress from there and see what we can do with this guy. Is it replace this power supply capacitor and she's going to work? There's a good chance of that. There really is. Maybe not work well, but work. It's possible. Okay, so well, thanks a lot for watching this first video, and have a great day, and we'll see you tomorrow.